you're probably familiar with another very popular differentiation rule. That's the quotient rule. Essentially tells you that if you're looking at the quotient of functions like j of x here, which is a quotient of f of x over g of x, you differentiate it essentially by following this rule. It's the derivative of f of x times g of x minus the derivative of g of x times f of x divided by g of x squared. But how do we actually get to this rule? Perhaps some of you have already seen the demonstration, but many have not. And in Physics 101, before we can use this rule, we need to actually prove it, demonstrate it, or derive it. So let's do it. We're going to follow a very similar strategy to what we've just done for the product rule. And then there's a trick, something that we can add and subtract. We'll manipulate the limits until we get to this result. So bear with me. First thing that we probably want to do is to write down what it is, the derivative from first principles of this function. We already know that j of x is f of x over g of x, which means that j of x plus h is f of x plus h over g of x plus h. We have the two basic ingredients. We can therefore sub it into a formula. This means that the derivative of j of x is the limit when h goes to 0, and I'll sub it in directly, of f x plus h g x plus h minus f of x over g of x divided by h. And I know many of you don't love fractions, but again, just like we've done before, we can actually get h over here, because essentially what this means is we're multiplying this by 1 over h. So that makes it much easier. Let's do that then. So this means this is equal to the limit when h goes to 0. We're taking h here, essentially just saying exactly the same thing. F x plus h. The other thing that we can do is find the common denominator. In this case, we'll get g of x plus h times g of x. So it means we need to multiply here g of x and divide by g of x. So we end up with g of x plus h, g of x. And in this case, we've multiplied and divided by g of x plus h. Therefore, we have minus f of x times g of x plus h. So far, so good. We've been able to get rid of the scary way of having a quotient. We got the h here, and we found a common denominator. So, success. Once we get to this stage, what we want is a small trick, something that we can add and subtract, so we can then split these terms and get to something like this. In this case, what we're going to do is subtract f of x times g of x and add f of x times g of x. This is what we're going to put in here. This is okay, again, because it cancels out. We're essentially adding 0 to the expression. Let's try it then. If we do that, this is the expression that we get. Remember, what we did going from this step to this step is we've subtracted f of x times gx and added f of x gx, which is more than allowed. We're keeping the balance. This is not really adding or subtracting anything from the expression. What we're going to do now is to start splitting the limit. We can actually see here f of x plus h gx minus f of x gx. And we're going to break that apart, and we're actually going to split this the other way around. We're going to write this as f x plus h g of x minus f x g of x divide as g of x plus h g of x, and we're going to subtract. We're going to take the minus out. This means we can write f of x g x plus h minus, because we've taken it out, f of x times gx, closing the brackets. And I know it is long, but you also have all the details in the lecture notes that you can check, just in case any of my f's or g's are a little bit confusing. Once we get to this stage, we can start to progress even more. We can notice that we have terms that we can cancel out. In this case, we can cancel out g of x in all of these, which is great. We can make this simpler. The problem is, going on a board like this and not in a real lecture theater has some challenges. So what I'll have to do is get rid of the top. If you have to go back, the nice advantage of being a video is you can just go back to the minute that you want and you'll check it back. The other really great thing about this being a video is that we can use magic to make things disappear. So let's take that opportunity. We have space now, and I'm going to carry on this side of the board. Having got g of x, the other thing that we can start to do is apply the properties of limits and try to get closer and closer to the quotient rule. What we're going to do is this term 1 over h, we're going to combine it with what's left here, which is f of x plus h minus f of x. This means we'll be able to recognize that as a derivative of f of x from first principles, and we'll see what remains. Let's try it. We've written this part, which means we still have the term which is 1 over g of x plus h, and that is also still being affected by the limits. The properties of limits, though, tell us that the limit of the product is a product of the limits, so we can use that. So far, we've dealt with this part, but we also have this component. Again, if you remember the properties of limits, the limit of the subtraction is the subtraction of the limits, but we should not forget about this 1 over h. Sometimes when you are doing a derivation, you forget terms. Perhaps if you go back in the video, you'll realize that we didn't write down one of the terms, which is g of x plus h times g of x. I've just gotten it back because this is crucial for the rest of the expression. Now that we have the term back, we can actually get the derivation going. And it means we also want to group them in a way that we can recognize the derivative of g of x. In this case, a nice way to do that is to realize that both terms are being affected by f of x. Therefore, we can write this as minus the limit when h goes to 0 of g x plus h minus g of x divided by h times the limit when h goes to 0 of what is left here, which is f of x divided by g of x plus h g of x. The difficulty is these things can be very long, which in a whiteboard like this is not ideal. Also, even with a piece of paper like this, it may not be the best. This is great. I mean, it's not so great that it doesn't even fit on the board, but it is great because we can finally make it much simpler. We can recognize that this is a derivative of f of x. We can also see that this term is the derivative of g of x. And as we shall see, we can actually take these limits. They're relatively easy. The limit when h goes to 0 of g of x plus h is just g of x. It's very simple. And when we look at this limit, the limit when h goes to 0 of f of x over g of x plus h g of x is just f of x g of x squared, because this simply goes to 0. It means that what we have there can be written more simply as derivative of f of x divided, because this is multiplying by 1 over g of x, so it's divided by g of x, minus the derivative of g of x multiplied by f of x over g of x squared. We are almost there, but let's use some final physics 101 magic to get rid of this. Final step that we need now is just to find a common denominator. In this case, gx squared, which means we'll be multiplying up and down by g squared, getting us the derivative of f of x times g of x minus, nothing happens here because we already had the common denominator, the derivative of g of x times f of x divided by the common denominator, which is g of x squared. This means we were able to obtain the quotient rule completely from first principles. It also means that if your teacher taught you this rule, you've been using it all along, but you've actually never proven it, it is true. It is correct. You can use it. It means we've added another rule that we've demonstrated or proved, and we can now use in a systematic way to tackle even more functions.